Welcome to rebuilding a Stuart Models twin launch model steam engine. This is part 13, fitting the crankshaft and machining the flywheel. And I just knew this flywheel wasn't going to fit. If you watch my video with the Stuart 1010, where I showed stupidly painted parts that were badly made, this is yet another example. Here's the flywheel from the 1010. And what's this? Shock horror, a contradiction. This is very gaily painted, but it fits the crankshaft. This crankshaft, the one that I've just made, has a shaft diameter of 5/16 of an inch, and this Stuart 1010V flywheel has been machined to accommodate a 5/16 of an inch crankshaft, which is a larger diameter than is shown on the original drawing. This flywheel will be perfect for the 1010V rebuild once I've built a new crankshaft for it, which will be 5/16 of an inch in diameter to match the bearings, which are also that size. So what I'm about to do is repair this flywheel and make it a good fit on the new crankshaft. But before I do that, I'm going to fit the crankshaft into the main bearings of the engine. In an earlier episode, I marked the top caps so I know where they go. I'm fitting them in position, and I won't know how well the crankshaft fits to the main bearings until I get the top caps in place. This is the first one in place, and it looks like a sloppy fit, but it actually isn't. Now I'm fitting the middle top cap. This is the part that normally goes very wrong on a lot of engines. If the crankshaft is out of alignment, the centre one becomes a clamp and stops the crankshaft from rotating. The third top cap was not an impressive fit, so I'm removing a little bit of metal from the cap itself, not forgetting to clean the particles off with a cloth before refitting it. I'm hoping that once this top cap is tightened down, it's going to be a good fit on the crankshaft. In this clip, I'm using the socket to just make sure that all of the nuts that hold the top caps in place are tightened correctly. Once again, if you're new to this sort of thing, it is not a car engine. You are not tightening up a cylinder head with a torque wrench. You have to be very gentle. The studs will shear quite easily. And also, these top caps are just made of gunmetal, which is quite a soft metal, so if you over-tighten them, they will distort. When I give the crankshaft a spin by hand, it really does feel very free. And the lubrication is not just fine machine oil to make it look freer than it is. This is steam oil mixed with rapeseed oil mixed with a little machine oil. I've assembled the engine loosely in as much as I've put the top bit on the bottom bit, and what I'm going to look at is the position relative to the crankshaft of the connecting rods. These connecting rods need to be perfectly aligned to the piston rods when the big end of the connecting rod is sat in between the crank webs. And as can be seen in this clip, everything is fine. Well, apart from this flywheel, which is a real rattle fit on the crankshaft. But I'm going to show you how to fix this now. Badly machined parts are very common in home-built steam engines, and this situation can occur due to a variety of reasons. It may be a first attempt from someone, or it just may be that they don't have the equipment. And now, with the help of my old, but slightly cleaner Boxford lathe, I'm enlarging the hole in the centre of the flywheel. And this drill size is one imperial drill size less than 3/8 of an inch. What I'm doing at the moment is using the back gear to slow the lathe down, because I'm using a reamer and I want the hole to be an accurate 3/8 of an inch in diameter. A good tip: if the speed of the lathe is too fast, then the reamer will rattle about and cut over size. What you need is a nice slow feed and a nice slow speed. So now we have a hole down the centre of the flywheel, which has been accurately reamed with a 3/8 of an inch diameter reamer. So all I need to do is apply some Loctite 603 to this piece of steel bar, which is also 3/8 of an inch in diameter, but it's not silver steel, so it's not a ground finish, and it fits perfectly in the hole in the flywheel. I'm turning it round and twisting it to make sure that I get a really good even coating of 603. And all I have to do is press this into the hole, and bear in mind it's longer than it needs to be, so it will be sticking out at the other side. Giving the Loctite some time to grab is a good idea. In this case I didn't really give it long enough, but everything was fine. First of all, I'm taking a facing cut across the entire front of the flywheel, and it's at times like this that I'm quite pleased that this old Boxford, even though it looks a bit horrible, is quite accurate. I'm speeding up the lathe now because I'm using the centre drill to make a hole in the middle part, and of course the middle part is now steel, and the feed and speed for steel is very different to the feed and speed required for cast iron. Once I drilled the centre hole, I removed the centre drill and replaced it with a twist drill, which is 1 imperial size less than 5/16 of an inch diameter. If you watch the way that the swarf is coming out of this twist drill, it's quite good. It's very even at both sides. So after I drilled all the way through, I then used a 5/16 of an inch reamer as before, but of course previously it was a 3/8 of an inch diameter reamer. And just as before, I slowed down the lathe. In the home workshop, when using a reamer, use the rule a slow speed and a slow feed, because this seems to work and you get a very accurate reamed hole. In industry, things are very different. There's time to take into consideration. It has to be done quickly. Everything's flooded in coolant to keep the temperature and friction down. But these things are quite difficult to achieve in a small home workshop with a small lathe, and you certainly do not want industrial coolant splashing about everywhere. This of course is the other side of the flywheel. I turned it round in the chuck and machined away the excess piece of steel from the centre, and then I very carefully used some coarse sandpaper to kill the edge. The last thing you want on a flywheel is a sharp edge. And now the fit of the flywheel on the crankshaft is everything that it needs to be. But I do want to replace this very small grub screw. In my opinion, it's far too small. So it's over to the drilling machine and I'm enlarging the existing hole to 1/8 of an inch in diameter, which is the tapping size for a 4BA thread. This is going to be a very long thread. The cast iron is quite soft and it doesn't grab as much as steel. In this clip, I'm carefully putting the reamer through the centre of the flywheel again, because as the thread breaks through into the hole in the centre of the flywheel, there's a slight burr, so I'm just really deburring it with the reamer. All I need to do now is assemble the whole thing, starting with the eccentrics. I'm not going to tighten these up yet. Both of these eccentrics are quite a slack fit on the crankshaft, just like the flywheel was. But once these grub screws are tightened up, they're going to be fine. And of course the last thing to go onto the crankshaft is the flywheel. And after I've tightened up the grub screw, we're ready for a bit of a test. And the first and obvious thing to do is to spin the flywheel with my finger. And the whole assembly spins very freely. I'm sure someone out there will think, well, the flywheel's wobbling about. No, it isn't. The entire engine's moving on the wooden baseboard. Here's a top tip. You might find this very useful. This is a very small drum sander, and I'm just removing the part that does the sanding from the rubber roller. I'm now tightening up the nut to hold it in place, and I'm going to put this in my Minicraft drill and use it to drive the flywheel. Some people run the steam engines in the lathe, some people put an electric drill on the end of the crankshaft, and neither of these ideas I particularly like. Nothing can go wrong here. Should anything foul up or suddenly stop, all that's going to happen is the little rubber wheel will skate off the flywheel, and that will not damage anything. And just to finish off, here's a very small bit of painting. I put some epoxy resin in the hole in the centre of the baseboard. So what I'm doing now is giving it yet another coat of black paint because I'm determined to waterproof this centre section thoroughly. Also, I'd previously rubbed down the mahogany part, so using some polyurethane varnish and a cloth, I'm applying another coat. I don't want it to be too shiny, so I sort of wipe on the coat and wipe it off, and it's starting to look okay now. As always, thanks for watching and I hope you found it useful.